This video covers vocabulary of sets and counting along with an example of using the various notations connected with these vocabulary terms. A set is a collection, and the notation that we use for a set has commas in between each element, and on the outside of the set, curly braces or brackets. So you're going to see sets described with a curly brackets and commas between every element. Now there are two types of sets, a finite set and an infinite set. A finite set has a specific number of elements. And one example I have here are the types of fingers. You have an index finger, a middle finger, a ring finger, and a pinky. We could also have a finite set such as the types of cars you own. An infinite set has infinite number of elements in it. An example of that is whole numbers. Okay, inside this particular example for whole numbers, I have the three symbols ... and that indicates that the set continues infinitely in that direction. Another vocabulary term is element. Element is a member of a set. Now there is something called a universal set, and sometimes they're not clearly stated what the universal set is, but the set contains everything. That's what the universal set is. But it's not like everything in the whole world, so I can't say that it's all the rocks and the mountains and the rivers or all the people. It's instead specifically to the problem that we're looking at. So if I say, the question is, all students enrolled in M115 at Helena College fall of 2017, then the universe is a listing of all the students in that class. The universe would not be all students at Helena College because I've limited it to just those in Math 115. Okay. The notation that we use for a universal set is a capital U. A lot of times it's more of a cursive italic type of U. Now that we have those basic definitions out, let's take a look at some other ones that we see frequently when we're working with sets and counting. The first one is union, and we're talking about the union of two sets usually. Sometimes it could be more. But union is written with this capital U symbol. So the first thing is an A, and that tells you that your first set is being called set A, and your second set is being called set B. And the U in between is telling us that we're finding the union of set A and B. And typically it's read A union B. Okay. The set A union B contains all elements in set A and in set B. If an element occurs in both sets, only one is written. An example that I tend to work with has to do with when two people move in together. They could be roommates or they could be a couple, whatever it is. But if two people move in together, usually there's an example of, let's say I move in with my husband before we got married. Well, we both had certain things. We both had dictionaries. I know it's kind of old school. You guys have them on your phone now. But we only needed one dictionary. So we only had one. We got rid of the other. And we had a bed. We only needed one of those. So when we talk about the union of our stuff, we're talking about everything I bring in and everything my husband brings in, and that's the union of our things. But we really only need one of each, so we only write like one bed or one knife. Okay, let's take a look at intersection. With intersection of two sets, the intersection is written A intersect B. This upside down U, I typically think about it as like a capital A, maybe a curved capital A. And the reason I think about it that way is eventually with counting, when we say the word and between two sets, we're talking intersection. So if we can think about this upside down U as kind of a and, then it helps us later. It is read A intersection B or A intersect B. The set A intersection B contains only the elements that are in both sets A and B. So if I go back to that example of two people moving in together, if I bring all my kitchen items and I have a blender and my husband has a blender, my husband has a knife and I have a knife, then only the things that we both have are in the intersection. Well, back up in the union, if I had a bathrobe and he didn't have a bathrobe, it would still be in the union, because union is everything we own, while intersection is just what overlaps and what we own. All right, disjoint. Disjoint sets. These are two sets that have no intersection at all. And when we have no intersection at all, A intersection B then equals this null set. The 0 with a line through it means null set. I know some people write their zeros that way, but this a little symbol here does not mean 0. It means that there's nothing in that particular set. It's the empty set. Subset. Subset. Let's say I have a set B and it's a subset of set A. What that means is every element of B is an element of A. And the notation for that is B, the sideways U with a line under it, and an A. Okay, so that's subset. And let's see if I can come up with an example. Okay, so if we take that set A is all the grandchildren that my parents have, and set B happens to be my children, then we can say that all my children are a subset of my parents' grandchildren. A complement of a set. This one tends to be pretty useful, and it may not be apparent how useful it is until later. A complement is the elements in the universe that are not in set A. Okay, so if I go back up to kind of the idea of the couple, and we have everybody's stuff all put together, and that happens to be our universe, is all the stuff that that couple owns. Then if I had let A equal all the stuff that I own, then a complement is all the things Kim does not own. Let's see, not owned by Kim, that would be better. Okay, let's take a look at a further example that helps us walk through those. I took two generic sets. I call them set S and set T, and I also created a universe. So my universe are all the numbers that are multiples of 4 up to 24. And my set S are multiples of 8 up to 24. And then I have just two random numbers in set T. They're 20 and 25. So the very first thing I'm being asked to do is I'm being asked to find and list the elements of S prime, or the complement of S. So the complement of S is everything not in S, but is in the universe. Okay, so the universe is what I really have to worry about, and I want to find out what's in S over here. And then I want to focus on what's not in S that is in the universe. So I can see that there is a 4. I don't want to write the 8. There's a 12. I don't want to write the 16. There's a 20. And there's a 24 in S, so I don't want to write that. S complement, only write the things in the universe that are not in S. Okay, part B, the union of S and T. Right, so for the union of S and T, I want to list everything in S and everything in T. If a number occurs in both sets, then I only write it once. Okay, so I write everything in S, and I write everything in T, and that is the union of S and T. But typically we write these in numerical order. So I notice it says 8, 16, 24, 20. That means I want to move this 20 and 24 So it reads 20 and then 24. Generally, we try to arrange our answer from smallest to largest. Part C, S intersect T. I want to find what S and T share. So I look at S, I look at T, and I decide, are there any values in common? And there's no values in common, so this is a null set. There's no intersection. Okay, now we're going to get into part D and E, and these are a little more complicated. So I want to introduce something called a Venn diagram. A Venn diagram starts with a box to represent the universe. Within that, I put my set S, and you can label it S inside the circle or outside, and then a circle T, and you want to overlap these. Okay, in S, I have 8, 16, and 24. I have 8, 16, and 24. And in T, I have 20 and 25. Now, if any of these numbers had been in common between the S and the T, I would write that in the middle, in the intersection. I'd only write it one time. I'd write it in the intersection, and then I would erase it out of this other outside the overlapping circles. So this section inside where the two circles overlap is the intersection of S and T. And where the two circles are completely, if I just drag those circles out, this happens to be the union of S and T. Right, so let's come back to D. D says S complement. So I want to look at things that are outside S. I want to look outside S. So that's everything outside circle S. Now, I have to remind myself that there was this universe, and this universe had the number 4. And I don't see 4 written in any circle, so 4 is out in this universe. 8's already written in a circle. 12 is not written. 16 is written in the circle. 20 is written in that circle, and 24 is written in a circle. Okay, so I have everything from the universe represented somewhere in my rectangle. So when I look at things that aren't in S, I am going to look at everything outside circle S. Okay, all those are outside circle S. And I want to look at intersecting with T. So intersecting with T, here's my circle T. I want to decide where the yellow and the green had overlapped. I know it's hard to see where the yellow and green overlap on a tablet because they just kind of merge colors there. But it happens to be right here with just the 20 and the 25. Not in S is everything outside circle S. And I want to be not in T. So not in T is outside circle T. While I'm doing this, I want to think about where these two colors overlap. Okay, so the yellow and the blue overlap, making this green color. Not in T. Great. So the intersection of the yellow and the blue color is the green. And that means the intersection occurs outside at the universe and is the set for 12.